Before we dive into the details of the APIs and the SDKs, just want to give you a quick introduction of Brevis as a whole. Brevis is a smart off-chain verifiable computing platform. It is fundamentally a scaling solution. Basically, we have a very limited computation capability on blockchain. You can actually use Brevis to offload these computation to an off-chain environment. In that off-chain environment, you can run that computation, but not only just the computation itself, but also generate a ZK proof of that computation result. And you can then submit both the proof and the computation result back to the blockchain, where you can simply and cheaply verify the computation result. It becomes a glue point of verifiable computation resources. What this means is that you can actually expand and scale blockchain computation to an infinite level. We built something called a ZK Coprocessor as our first flagship product. ZK Coprocessor allows your smart contract to have access to historical on-chain data, such as event, transactions built using Brevis. One good example is intelligent DeFi, where you can dynamically change the protocol parameters of DeFi projects. For example, you can actually run a trading volume-based fee discount. You can also do consumer-facing applications. For example, we partner with Euro, which is a rising star in the stable token space, and we power their token launch program instead of one-off airdrop. Now you can allow users to continuously generate proof of their interaction with the protocol and convert that into a quantitative matrix. So this allows you to actually merge and align user incentives with your protocol growth by having this continuous evergreen program of token drops. There are many other things you can do with the Brevis pre-confirmation. You can essentially prove to the blockchain whether a certain block producer have included your transaction or not in the past, and you can do slashing and rewarding based on that. Using Brevis SDK is quite simple. You specify what kind of data you want to read, what is the computation logic you want to run, and finally, you have your entire computation logic integrated in the smart. A very specific example of how you can build with Brevis using a Uniswap v4 hook example, but you can generalize that to other applications as well. Michael.
We're going to summarize the trading volume of a specific user on Uniswap. I'm going to focus less on the Uniswap v4 hook in this talk, but more on the Brevis side. First of all, let's look at how a Brevis app workflow looks like. As you can see, we have multiple components. We have the app service, the Brevis service, and the contracts associated with the app and Brevis. And the first step is pretty standard. You just use any sort of indexer, or you can just build your own to get the historical blockchain data from on-chain. And then you feed all those data to the app service, which in the rectangular blue box that you built. And all those data gets fed into the app circuit, which is also one of the components you guys will build. And then once you have all those data processed by the circuit, you generate your part of the proofs, and then you send all those, and then Brevis is going to combine to generate the final ZK proof to be verified on the Brevis contract for any sort of post-processing logic. For example, in the Uniswap case, as soon as you get a sum of all the trading volume for the user in the past 30 days, you can assign the user a VIP status based on their trading volume. With Uniswap v4 hook, you can lower the swap fee for that particular user, which is quite useful. This is essentially a simplified version of what I just talked about. And in this case, we provide a TypeScript SDK or a Golang SDK, whichever you prefer. And you implement the prover service, which we have a template for, and you don't have to write any code essentially. And you just submit your proof. You guys will implement the app circuit, which we also have very extensive examples. This is based on our TypeScript SDK. We also provide a Golang SDK, as I said, and you can pick connection to the app prover, which was the top blue box. We have a template for, and you don't have to actually worry about implementing that. Once you establish a connection, you instantiate a new proof request, and you're going to building all the data. So in this case, we're looking at Uniswap swap events, and it's a little bit technical, but you can see that you provide a transaction hash, a swap event, and the USDC transfer event. And the data we care about is amount 0, which is the USDC amount, and also the recipient. This is the Uniswap. They have the router contract set up. Actually, recipient is supposed to be the Uniswap router. And with all those, we start writing the circuit. So that was the providing the data point. If you're using TypeScript, this is going to be done in TypeScript. The actual circuit, we still have to use Golang. And in this case, you don't need any storage or any transactions. You just need the receipts, and you can specify a max number of receipts. How many of you guys know MapReduce, basic functions to calculate minimums or calculate sums from the common statistics use cases? But you can also use the for loops if you choose to, if that makes things easier as well. So in this case, we first do a map over all the receipts and extract the block number. And once we have the computation done, we need to output the results so that the on-chain contract can make use of it to say like assign VIP status or give our reward. We also need the minimum block number for the on-chain verification. And we also need to output the actual user address to make sure it is for that particular user. And this is the on-chain contract part of the Brevis application. In this case, we don't actually do anything with the output. We just emit a trading volume or test it. But in reality, you can just do whatever. You can put all that in a Uniswap V4 hook, so you can lower the trading fee for the user. And this is the actual decode logic, which it's a little bit intimidating, but it's actually quite simple if you just read through it. You basically match whatever the circuit has. In the comment section, you see all those API dot. You're essentially just extracting different bits or bytes from the output, and you return that. And here are a few links that can help you get started. We have pretty extensive documentation and examples. Just go to docs.brevis.network or check out either one of the two SDKs, whichever language you prefer.